Welcome to viewers. We are discussing here properties of parallelogram. Earlier we find that in a parallelogram opposite angles are equal, right? Opposite angles of a parallelogram are equal. Then we also find that diagonals of a parallelogram bisect each other at their point of intersection. That means these two parts are equal and these two parts are equal. Now we'll discuss the properties of a rhombus here. Now what is a rhombus? A rhombus is a parallelogram in which all sides are equal. So let us imagine this parallelogram ABCD. ABCD is a parallelogram and in which all sides are equal. So a rhombus, this is called rhombus. So a rhombus is a parallelogram in which all sides are equal. Right, now a square is also a rhombus. A square is also a rhombus since all sides in a square are equal, right? And beyond that, all angles are right angles. Means each angle is right angle. So square is also a rhombus. But every rhombus is not a square. For example, this is say PQRS. PQRS is a square. ABCD is a rhombus. But ABCD is not a square. That means difference is in a square all angles are right angles, whereas in rhombus all angles may not be right angles. That means every rhombus is not a square, but every square is a rhombus. In this rhombus, diagonals are not equal. BD is longer than AC, whereas in this diagonal here, you'll find that diagonals will be equal. Then one more thing we will discuss here, rectangle. A rectangle is a parallelogram in which diagonals are equal. Earlier we find that diagonals bisect each other, but diagonals are not equal. But this is a parallelogram in which diagonals are equal. Right? This is called rectangle. That means PR equal to QS. So a rectangle is a parallelogram in which diagonals are equal. But every square, you will find that every square is also a rectangle, because here also you will find diagonals are equal. So every square is a rectangle, but every rectangle is not a square. For example, this PQRS is a rectangle, but it is not a square because all sides are not equal here. Only opposite sides are equal. But in a square, all sides are equal, all angles are equal. In a rectangle also you will find that every angle is 90 degree here. In a rectangle, every angle is 90 degree. Rectangle is a parallelogram in which diagonals are equal only. Now let us join this diagonal, and then you join this diagonal, P, Q, R, S. Now if you consider these two triangles, say this is P, Q, R, and if you another triangle, this one, this is S, R, Q. You see that QR equal to QR, common side, PQ equal to SR, PQ equal to SR, opposite sides of parallelogram, right? So QS equal to PR, since by definition in a rectangle diagonals are equal, so these two triangles are congruent, right? Now, if they are congruent, corresponding parts are equal. Angle PQR equal to angle SRQ, right? But angle PQR plus angle SRQ equal to 180 degree. In a parallelogram, a pair of adjacent angles are supplementary. That means angle PQR and SRQ, they are supplementary. And since they are equal, therefore PQR equal to angle SRQ equal to 90 degree. Sum total is 180 degree, and since they are equal, so PQR and SRQ, they are right angles. That means in a rectangle, all angles are right angles. Similarly, in a square, since square is a rectangle, so this condition will apply in square also. Every angle in a square is right angle, right? Now we'll discuss one more important property of rhombus here. Say this is a rhombus. ABCD is a rhombus. Now let us join the diagonals here. Say this is O, right? Now in a rhombus, you know all sides are equal, so AD equal to AB, right? AD equal to AB. Then since they are equal, therefore these two angles are equal. ABD is a isosceles triangle. Isosceles triangle. In isosceles triangle, angles opposite to equal sides are equal. So these two angles are equal. Then again you find BO equal to OD, right? In a parallelogram, diagonals bisect each other, so BO equal to OD. So in these two triangles, you see, in triangles AOB and triangle AOD, so you find that AB equal to AD. Since it is a rhombus by definition, all sides are equal, AD equal to AB. Then you find BO equal to OD, right? Diagonals of a parallelogram bisect each other, so BO equal to OD. Then you find AO equal to AO, common side. Therefore these two triangles are congruent. Triangle AOB congruent to triangle AOD, right? Since they are congruent, so we find that angle AOB equal to angle AOD. CPCT. Corresponding parts of congruent angles are equal. Now angle AOB plus angle AOD equal to 180 degree. It's a linear pair. Therefore angle AOB equal to angle AOD equal to 90 degree. So we can conclude that AO perpendicular to BD. AO is perpendicular to BD. That means this angle is right angle. This angle is right angle means AC perpendicular to BD. That means diagonals of a parallelogram, diagonals of a rhombus bisect each other at right angle. They are perpendicular to each other. Rhombus is a parallelogram, so diagonals bisect each other. That is one property we got it earlier. But here again we discovered that in a rhombus, diagonals bisect each other at right angles. They are perpendicular to each other. So this is one important property. So if in a quadrilateral you find that diagonals bisect each other at right angles, that means it's a rhombus. If in a quadrilateral you find that diagonals are equal, you can say it's a rectangle, right? If in a rectangle you find that all sides are equal, then it's a square, right? So these are the basic properties of parallelogram. So we can conclude here the entire properties of parallelogram here. So let us find here. So we find that in a parallelogram, by definition, opposite sides are parallel. The definition of parallelogram is opposite sides are parallel. In a quadrilateral in which opposite sides are parallel, it's a parallelogram. Then we find that in a parallelogram, opposite angles are equal. Angle A equal to angle C, angle B equal to angle D. Then we find that in a parallelogram, opposite sides are equal, right? AB equal to CD and AD equal to BC, right? The definition of parallelogram is in a quadrilateral in which two pairs of opposite sides are parallel. That means AD parallel to BC, then AB parallel to CD. By definition of parallelogram, these are obvious, right? Now we find that angle A equal to angle C, opposite angles are equal, opposite sides are equal. Then we find that diagonals bisect each other. That means AO equal to OC, BO equal to OD, right? So if in a quadrilateral you can prove any of these properties, then it is a parallelogram. If in a quadrilateral you find that diagonals bisect each other, then it is a parallelogram. If in a quadrilateral you prove that opposite sides are equal, then it would be a parallelogram. If in a quadrilateral you find that opposite angles are equal, then it would be a parallelogram. Then we find that properties of rhombus. A rhombus is a parallelogram in which all sides are equal. Then we find that in a rhombus, diagonals bisect each other at right angles, right? AC perpendicular to BD. This is one additional property of rhombus. Rhombus is a parallelogram. So by definition of and by virtue of the properties of parallelogram, diagonals bisect each other at their point of intersection. That is, we already find here. Now the additional property of rhombus is diagonals bisect each other at right angles. Then we find a rectangle. A rectangle is a parallelogram in which diagonals are equal, right? ABCD. So AC equal to BD. By definition, this is the given property. It's a rectangle, diagonal cycle. Then we prove that every angle of rectangle is right angle, right? Then we come to square now. Now a square is a rhombus because all sides are equal. So this will satisfy the property of rhombus. So what was the property of rhombus? Diagonals bisect each other at right angles. That means in a square also, diagonals bisect each other at right angle. Additionally, a square is a rectangle because diagonals are equal. In a square, diagonals are equal. So a square is a rectangle. So every angle of square is right angle. So these are the properties of quadrilateral. So thank you viewers. We will do some exercise based on these properties of parallelogram in the next video.